Okay, I wanted to talk a little bit about the valence electron level. Okay, the valence it's very simplistic. It's the outermost electron level. Okay, outermost level. And we should be able to count valence electrons for any single atom. I'm just going to pick one randomly. I don't know. Let's do polonium. Okay, if I do the electron configuration for polonium, I get Xe. Okay, I'm doing the shortcut, obviously. I'm not going to do the whole thing. Xe, I'm starting at Xe, the last noble gas that I came across. And then I'm going to do the 6s2, the 5d10, the 4f14, and the 6p1, 2, 3, 4, 6p4. And okay, first of all, that's my shortcut electron configuration for polonium. And the question would be now, how many valence electrons does polonium have? Okay, how many is in the outermost electron level? And the answer for polonium for its valence electrons, I'm just going to call it VE. Okay, the VE, how many VE electrons? It has 6 valence electrons. Okay, 6 valence electrons. 6 electrons in its outermost energy level. And the way I would describe this is, think of the atom as an onion or our nesting dolls. And the valence is actually what you could see. It would be the visible energy level. And it would be the outermost would be the visible one. Okay, of course, you're not going to see the interior. And we have the outermost energy level being the 6th energy level. And I have 2 plus 4 equaling 6. Okay, so it has 6 valence electrons. Okay, the D and the F, the D block and the F block, will never be considered valence because of our 2 rules. The D was always 1 energy level back. The F was always 2 energy levels back. So they're not considered valence electrons, only the S and the P. Okay, again, what's it mean? Outermost energy level. To pick something more simplistic, okay, let me pick something that's a little bit more traditional. What I mean by that is a little bit closer to the top of the periodic table. Pick something in the second line here. Carbon. Okay, carbon, I'll just write the whole thing. 1s2, 2s2, 2p2. Same thing. Its valence electrons. Okay, its valence electrons would equal for the number 4 because it has 2 from the S and 2 from the P. Pick something else. Pick something else. Let's do krypton. Okay, krypton, if I do Kr, I'm actually going to go all the way back to argon. Okay, because that's the last noble gas. Krypton's a noble gas, but argon's the last one I went across, I came across. And then I'm going to do the 4s2, 3d10, 4p6. Okay, I'm at krypton now. And krypton has how many valence electrons? Well, the outermost energy level, its outermost energy level is the 4th. It's not the 3rd, it's the 4th. So it has 8 valence electrons. Okay, it has 8 electrons in the valence. And that's actually the max. The maximum number is 8 because only the S and the P create the valence. Okay, so its secondary definition for valence is S plus P. Okay, and you know what? I think I want to just say the outermost S and P. The outermost S plus P. Okay, for example, if I pick anything in the center here, it has a valence electron of 2. Okay, because if I drew the structure, it would be krypton, If I drew the structure, it would be, the structure is krypton. And then I'm over here in the 5s2. Oops. All right, I'm over here in the 5s2. And then the 4d, 1, 2, 3, 4, 5, 6, 7. 4d7. The outermost energy level for my RH is the 5th, and it has 2 electrons in the valence. Okay, I could pick anything. If I pick anything from over here, it would have a valence electron level. Cesium would have one valence electron. Okay, if I pick something on the other end of the periodic table, such as okay, I'm sorry about that. If I pick anything from over here, bromine would have 1, 2, 3, 4, 5, 6, 7. Okay, note that I'm skipping the middle because it doesn't matter. They're not in the valence. The D's not in the valence. So bromine would have 7. All the noble gases would have 8. Okay, all the noble gases would have, a little apologetic for the sloppiness, all the noble gases would have 8 valence electrons, and then helium would have 2. Okay, helium has 2 VEs as a full valence, and the rest have 8 valence electrons, full valence. That's our valence electrons.